Have you ever tapped on an app and just wondered what actually happens behind the screen? It's not magic, it's code. And today, we're going to pull back that curtain on programming, starting right at the beginning, your very first program. So let's start with a kind of a weird question. How do you teach a rock to think? Now, I know that sounds a little crazy, but it's honestly the perfect way to think about programming. A computer, at its core, is basically just a very, very fancy rock, a piece of silicon that, on its own, does absolutely nothing. Our job as programmers is to give that rock a set of perfectly clear instructions to make it do something incredible. The very first hurdle we have to overcome is this massive communication gap. See, we think in words and ideas, but computers, they're incredibly simple. So let's take a look at how we actually bridge that divide. On one side, you've got a simple human idea. Say hello to the world. But to a computer, that idea looks like this long, messy string of ones and zeros. This is called binary, or machine code, and it's the only language a computer's processor actually gets. So how do we get from our idea to those ones and zeros? Well, we use a translator. First, we write our instructions in a language that we humans can actually read, something like C. We call this our source code. Then, this special program called a compiler comes in and acts like our master translator. It takes our source code and converts it into the machine code the computer needs. You can think of the compiler as the essential middleman in this whole conversation. All right, that's enough theory for now. It is time to get our hands dirty. We're going to write our very first program. It's a time-honored tradition for literally every new programmer. It's called Hello World. And here it is. This is our setup. Now, don't get overwhelmed by everything you see. Just focus on three things. In the middle, we have a text editor. That's where we write our code into a file we'll call hello.c. Then, down at the bottom, we have the terminal. That's where we're going to tell the computer what to do. Now, the real heart of our program is just this one single line. Printf is a function. It's basically a command that tells the computer to print something on the screen. And whatever we put inside those quotes, that's what gets printed. And that little /n at the end, that's just code for start a new line. It's basically like telling the computer to hit the enter key for us. Once we've written the code, we just follow this simple three-step process in the terminal. First, code hello.c opens the file so we can write in it. Second, make hello tells that compiler we talked about to translate our code into a runnable program. And finally, .hello actually runs it. And what's the result? The words hello world pop up right on our screen. It's really that straightforward. Okay, that was pretty cool, but let's be honest, our program is a little boring. It does the exact same thing every single time. So let's level up and make it interactive, so it can actually respond to a person. You can see the evolution right here. On the left is our original code, but on the right, we've made a really important change. Instead of just printing a message that's always the same, we're now using a new function called getString to ask the user a question and then wait for them to type an answer. So when the user types in their name, where does it go? Well, for that, we need something called a variable. A variable is just a container in your program's memory, kind of like a labeled box. We can name our box answer, and we can use it to hold on to information that might change, like someone's name. And if you look closely, you'll see our printf command has changed too. We now have this little %s placeholder. That's a special code that tells the program, hey, don't print these two characters. Instead, go find the box labeled answer, grab whatever's inside, and stick it right here. This is what makes our program feel alive and dynamic. Awesome, so our program can now remember things. It can talk to us. But to make it really useful, we need to give it a brain, the ability to make decisions. It's time to add a little logic. The most basic tool for this is the if-else statement, and it works pretty much exactly how it sounds. If some condition is true, do one thing. Else, do a different thing. It creates a fork in the road, which lets our program choose a path based on whether something is true or false. Okay, listen up, because this is a super, super important detail. A single equal sign gives a value. It's like saying x equals 5. But a double equal sign, that asks a question. If x equals 5 is asking the computer, hey, is x equal to 5? Getting these two mixed up is one of the most common mistakes new programmers make, so it's a really good one to remember. So far, we've taught our program to remember, to interact, and to decide. So what's next? Well, we need to teach it how to do things over and over and over again without us having to write the same code 1,000 times. This is the power of repetition. To do this, we use something called a loop. A loop is just a structure that tells the computer to repeat a block of code again and again. It's the key to unlocking the computer's true superpower, doing a massive amount of work with just a tiny bit of code. Let's see what that actually looks like. Using a simple for loop, we can tell the program to run one action 4 times. In this case, that action is just print a question mark. And the result? We get a perfect row of 4 blocks. Simple, right? Now watch this. With one tiny little change, just adding that new line command inside our loop, we get a completely different result. Instead of a row, we get a column. This just goes to show you how powerful even small tweaks inside a loop can be. And this is where it gets really cool. What happens if we put a loop inside of another loop? Well, that's called a nested loop. The outer loop can handle the rows, and for each of those rows, the inner loop can handle the columns. And just by combining these simple, repeating instructions, we can suddenly build a complex, 2-dimensional grid with just a few lines of code. This is the magic of programming. Okay, let's just take a step back for a second and look at everything we've put together. In just a few minutes, we've actually assembled the essential building blocks for almost any program you can think of. So here it is, your core toolkit. We've got variables to store information, we have conditionals to make choices, we've got loops to repeat actions over and over, and we have functions to organize all our code. Believe it or not, with just these 4 concepts, you have the fundamental building blocks to create almost anything you can imagine. You know, we started this by asking how to teach a rock to think, and now we know. With just a handful of core ideas, we can make that rock create patterns, interact with us, and even make decisions on its own. These are the fundamental tools of creation in our digital world. So the only question left is, what will you build?